So the next thing we're going to do is, if we're given a parabola, can we come up with the equation in vertex form? And remember, vertex form looks like this, right? Where we have the thing with the brackets and the squared, and that the h and the k value represent the vertex, right? So before we do this, I actually want to talk a little bit about the a value in front, because sometimes these parabolas are just multiplied by an a value. How does that affect the shape of the parabola, and why is it important? So let's go over here to this graph. And if we look at this graph, first of all, it just showed for a second, but if we're trying to graph this parabola, we know that the vertex is going to be at -2 and -6, right? So what does that look like? And we could do it a little more accurately. We can find another point, but for now I just want to show you. So that's the dotted line that you see there, right? There we go. So I showed it as a dotted line because I want to show you what happens when we add a number in front of that bracket, an a value. So you can see the red line is going to be the one that doesn't change, and I'm going to insert a value here. So for example, what happens if I make the value in front of that bracket a 2? Ooh, what do you notice about that blue equation, that blue parabola? How does it look compared to the red one, the original one? Well, it's sort of a little bit squished, right? It's like somebody are pinching it in on the sides to make it a little bit more squished. What happens if I make it a 3? So if I go in here, oops, if I can get the right spot, there we go. And if I make it a 3, what's it going to look like? It looks even a little bit more squished, right? If I make it a 4, what's it going to look like? Right? It's going to look like that. What if I make it a 5? It's going to look even more squished, right? So the a value, when you change the a value, it seems to change the shape of the function. It seems to make it a little bit more squished if you increase that value. And in fact, if I change this into a general value, I'm just going to make it into an a so that we can add a slider for it. So when a is 1, it looks like the regular parabola, and when I increase the value of a, you see it's going to get tighter and tighter. It's going to get basically more and more squished. We actually call this a stretch because it's like somebody's grabbing it from above and stretching it upwards. So that's what happens when you stretch it, when you increase the a value. What happens if you make the a value smaller than 1, though? What if you make it like 0.5, for example? What's going to happen? Well, look, the parabola gets wider. Oops, there we go. The parabola gets wider. So there's a as 0.4. So when you have a number, like a decimal number, for your parabola, or for the a value, the parabola is going to sort of be this wider parabola. And I can make it even less, 0.4, 0.1, 0.2. So see how it's even wider? The question is, what happens when we make it so little that we make it negative? Well, look, the parabola flips around to the other way. So now that blue parabola is upside down. And that's what making the a value negative does. It makes the parabola basically open downwards. So the point I'm trying to make here is that the a value just changes the shape of the parabola, but it doesn't change where that vertex is. Notice how no matter where I change a to, that vertex always stays the same. So just keep that in mind when we do the next part of this lesson. Okay. So again, back here. Can we create an equation in that vertex form? Well, first of all, if we look at the first parabola, what are the things that we can pick out from here? Well, the most obvious thing is the vertex, right? So we know the vertex, and what's the coordinate of the vertex? If we look at it, the x part is going to be 2, and the y part is going to be 5. So the coordinate of the vertex is 2, 5. So if we remember our vertex form of our equation, remember, the vertex is that h and that k value. So what I'm going to do to solve this question, I'm first going to just copy out the equation of a parabola in vertex form. Y equals a x minus h squared plus k. And remember, the vertex is 2 and 5. So we're going to plug in where the h is, we're going to plug in a 2, and where the k is, we're going to plug in a 5. So y equals a x. Now, is it going to be minus 2 or plus 2? Well, remember, it's always the opposite sign of what the vertex is. So the vertex is at 2. So in the equation, it's going to be a minus 2 squared and then plus 5. So there we go. That's a pretty good equation for our parabola. We're actually almost done here. But what are we missing? Well, we don't know what that a value is, right? In order to come up with an exact answer for our vertex or our equation, we need to find the a. So how do we find the a? Well, just like when we were sketching it, we need one more point on this parabola. So we can actually pick any point on this parabola that makes sense. So like any point that falls on the corner of the grid lines, like that's a good point right there. So that's point like 1, 3. The y-intercept down here looks like a pretty good one too. That's 0, -3. Or we could choose this point over here or this point over. You can choose any point that falls on the grid lines. I'm just going to choose this one up here, 1, 3. And what we're going to do is we're going to put the 1, 3 into the equation, and then we're going to solve for y. So remember, when you have a point like 1, 3, remember that the 1 is going to be the x part of the coordinate, and the 3 is going to be the y part of the coordinate. So what I'm going to do is I'm going to plug in 1, 3 in place of x and y in our equation. So how's that going to look? Well, instead of the y, actually let me put this here. I'm going to plug in 1, 3 into the equation. So when I do that, the y is going to be replaced with a 3, right? The a still stays an a, we don't know what that is, but the x I'm going to replace with a 1. So now we have a little bit of a complicated equation, but we still don't know what a is. So all we have to do is simplify this, and it looks pretty complicated, but it's actually a lot simpler than it looks. Because if we just follow our order of operations and then solve for a, it's not going to be too bad. So how we do that? First of all, we can simplify this big mess here, right? 1 minus 2 is -1, so we can simplify that as -1. So 3 equals a times -1 squared plus 5. Well, -1 squared, so that's the next thing we do here. -1 squared is just 1, right? -1 times -1 is just +1. So this is just a times 1 plus 5. And now we can try to solve for a. So in order to solve for a, we need to get rid of that 5, right? So we can bring the 5 to the other side by subtracting 5 on both sides. 3 minus 5 is -2. And then 1a is just the same thing as saying a. There we go. So we found our a value is equal to -2. Now that we know our a value, we know our h and our k value, we can just replace the a in the equation to find our equation of our parabola. So all we got to write is the final equation. So instead of the a, I'm going to put -2. And then we know what the h and the k are, -2 squared plus 5. There we go. There is our final answer. There is the equation of our parabola. You know you've got the final equation when we've replaced the a value, the h value, and the k value with the proper numbers. In a final equation, you're still going to have the x and the y because that's what creates the equation, right? Just like the equation of a line is always y equals mx plus b. So there we go. That is how you create an equation of a parabola. That's a pretty complicated thing, but if you just follow the steps, you should be okay. And just to refresh the steps, what the steps are. So step number 1, what we did here was we plugged in the vertex, right? We plugged in the vertex as the h and the k value. Let me just highlight that just in case it's a little bit confusing. So we plugged in the h and the k value for the vertex. And then we picked another point and we plugged that in for x and y. Then we solved for a. So I'll write that out. Solve for a. And that's what we did here, right? And the last thing we did is we just wrote out the whole equation. So I want you to try the same thing with that next parabola, okay? Try it out for yourself. Pause the video. Try it. Unpause when you're done. So here we go. Here's my final answer is 0.5 x minus 2 squared minus 3. If you're a bit confused about how to find that, there's the steps. So first of all, I identified the vertex was at 2, -3. I plugged that in for h and k, like this. Then I found another point. And the other point that I chose this time that falls on the grid lines is 0, -1. I didn't want to choose this point right here because it's not like where the two crosses meet. This point's a lot easier to use. You could have also used this point right here, right? 4, -1. That also would give you the same answer. So then I plugged that in and then I solved for A. So notice how the difference between this one and this one is that at the end here I had to divide because it was A times 4. To get rid of that 4, I needed to divide both sides by 4. But then I got it. So the A value here was 0.5. And it makes sense because remember, when the A value is less than 1, when it's a decimal, the parabola looks wider. And that's sort of what this looks like in this case. The last thing to point out before doing the rest of the practice problems is that remember what the A value also tells you. It tells you if the parabola opens upwards or downwards. In this case, the parabola opens down. So that means the A value should be negative, which it was. It was -2. In this case, the parabola opens upwards, like a bowl. And we would expect the A value to be positive, which it was. It was positive 0.5. So that's a good way of just checking your answer. If your A value, if the parabola opens up, the A value should be positive, and if the parabola opens down, the A value should be negative. So now what I want you to do, I think you know what I want you to do. I want you to try these 4 questions yourself. Try to come up with an equation in vertex form of each one of these parabolas. So pause the video now, try it, unpause when you're done, and I will show you the solutions. So there's the solutions to A and B. The vertex is at -1, -3. The other point that I chose was 0, 0. If you solve for A should have given you 3, value of 3. So the final equation should have looked like that. Notice how, remember, for the vertex, we always need to change in the equation. We need to change the sign of the x part. So if it was -1 here, it's got to be +1 here, and +1 in our final answer. For part B, the vertex was at -2, 0. The other point that I chose was 0, -2. If you solve for A, it should have been -0.5. And this is your final equation. Notice how this one doesn't have a value at the end, a k value, because it's just 0. So you don't need to include in your final equation. You don't need to put +0 at the end because it's nothing, right? For the next one, the vertex was at 2, -3. So plugging that in, plugging in 0.1, -5, gave an A value when you solve for it of -2. So the equation, the final equation, should have looked like that. And lastly, the vertex here was at 0, 0. So you can plug in h and k as 0, 0. It doesn't matter if you put a +0 or -0 because you're taking away or adding nothing. And then the other point that I chose was 2, 2. When you solve for A, it gives you 0.5. So basically you got 0.5 x minus 0 squared plus 0. But remember, when you have a 0, when you're adding or subtracting 0, you don't really need to include those zeros. So you can simplify this as just 0.5 x squared. That's it, because this 0 goes away and this 0 goes away. All right, there you go. So hopefully now you have some idea of how to create an equation of a parabola in that vertex form. Again, it's a very useful form because in the equation we can very easily see what the vertex of the parabola is.